The code interpretation regarding pull boxes and junction boxes is that they are considered part of the raceway system. They do not require the full 4 feet of working space that is specified in Article 110.34 of the National Electrical Code. Exception 4 of this section applies to the back of dead front switchboards, panel boards, and motor control centers. This requires a minimum working space of 30 inches for de-energized parts, or 36 inches for energized parts. However, this exception does not apply to pull boxes or junction boxes. An inspector's concern about a pull box located above a starter may stem from a potential electrical hazard if the pull box becomes energized. To address this, ensure the pull box is properly isolated and energized before working on the starter. Here is a recommended course of action to take. Firstly, discuss the code interpretation with the inspector. Explain that the pull box does not require 4 feet of working space. Provide documentation or a code interpretation letter to support your position. Secondly, if the inspector is still concerned, explore alternative solutions, such as moving the pull box to a more accessible location. Or, you could provide additional protection against potential hazards. The inspector's concern does not necessarily mean it is a showstopper. It is important to address the issue promptly to avoid potential delays during the start-up process. Therefore, I recommend scheduling a meeting with the inspector to discuss the code interpretation and find a mutually acceptable solution. This will help to ensure a smooth and timely start-up. Article 110 contains requirements for electrical installations. This article is designed to ensure the safety of personnel and property from hazard arising from the use of electricity. Section 110.2 discusses the integrity of electrical equipment and systems. It states that electrical equipment must be installed in a neat and workmanlike manner. Electrical systems must be free from hazards. Section 110.3 covers examination, identification, installation, and use of equipment. It requires that equipment be suitable for the intended use and installed according to the manufacturer's instructions. Section 110.16 mandates ACT flash hazard warning. Electrical equipment likely to require examination, adjustment, servicing, or maintenance while energized must have a warning label. The label must warn qualified persons of potential ACT flash hazards. Section 110.26 specifies spaces about electrical equipment. It provides minimum working space clearances for personnel to safely operate and maintain electrical equipment. This working space is dependent on the voltage of the equipment and the condition of the surrounding area. Section 110.34 provides minimum clear distances for systems over 600 volts, nominal. These clearances are larger than those in 110.26 due to the increased hazards associated with higher voltages. Now let's delve into Article 314, which focuses on boxes, conduit bodies, and fittings. This article covers the installation and use of boxes, conduit bodies, and fittings used in electrical systems. These components serve as enclosures for conductors, splices, and terminations, providing mechanical protection and a degree of environmental protection. Section 314.3 outlines the uses permitted for boxes, conduit bodies, and fittings. It specifies that these components must be suitable for the environment in which they are installed, considering factors such as moisture, corrosion, and physical damage. Section 314.15 covers the positioning of boxes, conduit bodies, and fittings. It requires that these components be securely fastened in place and supported independently of the raceway system. This ensures that the weight of the conductors and other equipment does not place undue stress on the raceway. Section 314.16 provides rules for calculating the number of conductors permitted in a box. This calculation is based on the size and type of conductors, as well as the size and type of box. Overfilling a box can lead to overheating and insulation damage, so it is essential to follow these guidelines. Section 314.17 details the rules for conductor entries into boxes, conduit bodies, and fittings. It requires that conductors be protected from abrasion and damage when entering these components. This can be achieved by using bushings, connectors, or other appropriate fittings. Section 314.22 covers the construction requirements for boxes, conduit bodies, and fittings. It specifies that these components must be made of durable materials and have smooth, rounded edges to prevent damage to conductors. They must also be adequately grounded to provide a path for fault current. Section 314.23 provides requirements for the support of boxes, conduit bodies, and fittings. It specifies that these components must be supported independently of the raceway system and be securely fastened in place. This ensures that the weight of the conductors and other equipment does not place undue stress on the raceway. Section 314.25 covers the requirements for using conduit bodies as pull boxes, junction boxes, or splice boxes. It specifies that conduit bodies must be sized appropriately for the number and size of conductors they contain and must be accessible for inspection and maintenance. Section 314.27 details the mounting requirements for boxes and conduit bodies. It specifies that these components must be mounted in a way that provides adequate support and protection for the conductors and other equipment they contain. They must also be mounted in a location that is accessible for inspection and maintenance. Section 314.28 provides rules for calculating pull box and junction box sizes. This calculation is based on the size and number of conductors entering and exiting the box, as well as the angle of the bends in the raceway. Properly sized pull boxes and junction boxes are essential for facilitating conductor pulling and minimizing stress on conductors. Section 314.29 covers the accessibility of boxes, conduit bodies, and fittings. It requires that these components be readily accessible for inspection, maintenance, and repair. This means that they must not be obstructed by building finishes or other equipment. Section 314.30 details the requirements for the covers and canopies used with boxes and conduit bodies. It specifies that these covers and canopies must be securely fastened in place and provide adequate protection for the conductors and other equipment inside the box. They must also be suitable for the environment in which they are installed. Section 314.40 covers the marking requirements for boxes, conduit bodies, and fittings. It specifies that these components must be marked with the manufacturer's name or trademark, as well as other relevant information such as the type of material, the size of the box, and the maximum number of conductors permitted in the box. Now, let's look at Article 110.34, which specifically addresses working space and guarding for equipment operating at over 600 volts, nominal. This is particularly relevant in the context of a 4160 volt chiller installation. Section 110.34 addresses the space around electrical equipment operating at over 600 volts, nominal, and it includes specific requirements for working space and guarding to protect personnel. Section 110.34 details the working space requirements. It specifies that sufficient access and working space must be provided and maintained around all electrical equipment to permit ready and safe operation and maintenance of such equipment. The dimensions of the working space must not be less than specified in 110.34 AON, ATWO, and ATRI, unless elsewhere required or permitted in this code. These dimensions are based on the nominal voltage to ground and the condition of the installation. Condition 1 applies where there are exposed energized parts on one side and no grounded parts or grounded parts suitably guarded or insulated on the other side of the working space. Condition 2 applies where there are exposed energized parts on one side and grounded parts on the other side of the working space. Condition 3 applies where there are exposed energized parts on both sides of the working space, with personnel between. Section 110.34b covers the width of the working space. The width of the working space in front of the electrical equipment must be the width of the equipment or 3 feet, whichever is greater. In all cases, the working space must permit at least a 90-degree opening of equipment doors or hinged panels. Section 110.34c addresses the height of the working space. The workspace must be clear and extend from the grate, floor, or platform for the equipment to the height specified in 110.34a. Within the height requirements of this section, other equipment that is associated with the electrical installation and is located above or below the electrical equipment must be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Section 110.34d discusses entrance to and egress from working space. At least one entrance of sufficient area must be provided to give access to the working space about electrical equipment. For equipment rated 1200 amps or more and over 6 feet wide that contains overcurrent devices, there must be one entrance not less than 24 inches wide and 6.5 feet high at each end of the working space. A single entrance to the working space must be permitted where the location allows a continuous and unobstructed way of egress travel provided in 110.34 down. Section 110.34e specifies illumination requirements. Illumination must be provided for all working spaces about electrical equipment. The lighting outlets must be arranged so that persons changing lamps or making repairs on the lighting system will not be endangered by live parts or other equipment. Section 110.34f covers the requirements for guarding of live parts. Live parts operating at 50 volts or more must be guarded against accidental contact by approved enclosures or by any of the following means. Firstly, by location in a room, vault, or similar enclosure that is accessible only to qualified persons. Secondly, by suitable permanent, substantial partitions or screens arranged so that only qualified persons will have access to the space within reach of the live parts. Any openings in such partitions or screens must be sized and located so that unqualified persons are not likely to come into accidental contact with the live parts. Thirdly, by location on a suitable balcony, gallery, or platform elevated and arranged to exclude unqualified persons. Fourthly, by elevation of 8 feet or more or above the floor or other working surface. Section 110.34 contains exceptions. Exception number 1 states that existing electrical installations that do not meet the minimum clear distances specified in 110.34 must be permitted to continue in use subject to the approval of the authority having jurisdiction. Where changes or replacements are made, the equipment must comply with 110.34a. Exception number 2 addresses equipment installed on platforms, balconies, or in rooms or spaces that are accessible only to qualified persons. The working space requirements of 110.34 do not apply to such installations. Exception number 3 is regarding the back of dead front switchboards, motor control centers, and control assemblies. Working space is not required at the back of such equipment where all connections and all renewable or adjustable parts such as fuses or switches are accessible from locations other than the rear. Where rear access is required to work onto energized parts on the back of enclosed equipment, a minimum working space of 30 inches horizontally must be provided. The requirements for working space in this section are crucial for ensuring the safety of qualified personnel who may need to work on new energized electrical equipment. The specific dimensions and configurations of the working space depend on the voltage level, the presence of grounded parts, and the need for access to the equipment. Now, addressing the specific concern about the pull box located above the starter, it's important to consider the following. Firstly, ensure that the pull box is properly installed and grounded. This will help to minimize the risk of the pull box becoming energized. Secondly, verify that the conductors within the pull box are properly insulated and protected. This will help to prevent shorts and other electrical faults. Thirdly, consider the accessibility of the pull box for future maintenance and repairs. While the pull box may not require the full 4 feet of working space specified in 110.34, it should still be accessible for qualified personnel to perform necessary work. Fourthly, discuss the inspector's concerns openly and honestly. Explain the code interpretation and provide any relevant documentation to support your position. If the inspector remains concerned, explore alternative solutions that address their concerns while still meeting the requirements of the code. Lastly, remember that the ultimate goal is to ensure the safety of personnel and equipment. By working collaboratively with the inspector and addressing their concerns in a proactive manner, you can help to ensure a smooth and successful startup of the chiller installation. Always prioritize safety and compliance with the applicable electrical codes and standards. If there are any doubts or uncertainties, seek clarification from qualified professionals and the authority having jurisdiction. A proactive approach to addressing concerns and ensuring compliance will contribute to a safer and more reliable electrical installation.